this in a timely manner. So let's just take a look at the first one. So the first one is, when is the absolute value of a number less or equal to 2? Well, for that to happen, think about it. 2 would work, 1.9, right? Numbers obviously higher than 2 is not going to work. 2.1 is not going to work. So 2 works. Any number between 2 and 1, any number between 1 and 0, and let's keep going. Right, any number between 0 and negative 1, any number between 0 and negative 2, and any number higher than negative 2, lower than negative 2, smaller, right, like negative 2.1. If I put it over here, take the absolute value, it's going to be positive 2.1, and that's definitely not less or equal to 2. So here, I'll put a circle here, Right, the numbers that I can replace the x with and take the absolute value of are numbers between 2 and negative 2. So x has to be a number between 2 or equal to 2 or here. Okay, and if you write that in set notation, you can write it like that. And that means inclusive, right, as opposed to parentheses. Okay, that's simple. Next one, x plus 3 greater than 4. So again, I want you to focus not on just focus on this. Pretend it's just this for now. What is the absolute value of a number, right, greater than 4? For that to happen, right, we're going to look at 2 points here. In order to be greater than 4, it has to be 4.1. So if that was 4.1, and we took the absolute value, would that work? Yeah. That was 5, would that work? Yeah. 6, 7, and every number to the right of 4. And this time, it can't be equal to 4, so we're going to put an arrow that way. So if you pick any number on the number line that is to the right of 4, and just put it over here, right, in this space, it would be greater than 4. Don't worry about the x right now, so let's just focus about that. On the other side, this is negative 4, by the way. Any number less than negative 4, and we would put it over here, so let's say negative 4.2, we take the absolute value of that, it'd be 4.2, and that would be greater than 4. So any number to the left of negative 4 would work. So that's what is going to help us set our problem. So set up a problem, and this is an OR problem, right? This is going to be an OR problem, so I want you to keep that in mind. It's going to be an OR problem because it's greater. So we're going to have two situations. X plus 3 has to be greater than 4, or x plus 3 has to be less than 4. And that's what this helps us set up. It helps us set up our inequality. Now it's just a matter of solving it. So x greater than 1, and over here we're going to subtract 3 on both sides, and x has to be greater than 7. So let's graph this. So what this is saying is that x greater than 1, so here's 1, put a circle. So numbers greater than 1 will work, and on this side here, numbers less than 7 will work. So let's pick a number actually that's in between here. Let me pick 0 right here, just to prove you that the numbers between these two numbers, because they are not valid, let's just prove it. So let's pick x, 0. If I pick 0 and I plug it in here, I get 0 plus 3. 0 plus 3, 3. If you take the absolute value of 3, is that greater than 4? No. So that, and again, you can play around, pick negative 3. Negative 3 plus 3 is 0. Is the absolute value of 0 greater than 4? No. So you notice that these numbers inside here don't work. Okay? Now, pick a number to the right of 0. Pick 10. 10 plus 3 is 13. Take the absolute value of 13. Is that greater than 4? Yes, it is. Pick numbers to the left of negative 7. Negative 8. Negative 8 plus 3 is negative 5. Take the absolute value of that, we get 5. And is 5 greater than 4? Yeah, so all those work. So the answer to here is x. We're going to write the answer out. So x is going to be greater than 1, or x has to be greater than 1, or x has to be less than negative 7. Those are your two choices. Okay? All right, so again, this takes a little practice. 15, right? X plus 3 is less than negative 6. So this one is an easy one. All right, so I want you to think, when is the absolute value of a number less than a negative number? because this could be -6, -7, -1, -10, doesn't matter. So when can you take the absolute value of a number and it's going to be less than -6? Let's pick a number. I don't know, 1,000,000. Is 1,000,000 less than -6? No, that doesn't work. How about -1,000,000? I take the absolute value of that. It's a positive number, right? So no matter what you take the absolute value of, it will always be a positive number. So over here, you'll always end up getting a positive number. And is a positive number ever going to be less than 6? No. So for number whatever 15 is, no solution. Okay. 16, we have 3. So again, here you have 2 multiplied by the absolute value of -2x minus 4 greater or equal to -9. So let's do this. The first thing we do is we're going to simplify this a little bit. So we're going to divide this side by 3 and divide this side by 3. Now we have the absolute value of 2x minus 4 is greater than -9. Let me put this. Now this one is almost the opposite of the previous one. That's question 15. So when is the absolute value of a number greater than a negative number? You can take the absolute value of anything. It's going to give you a positive number. And isn't that always going to be greater than -9? Yes. So your solution is all real numbers, right? All real numbers. Okay, so again, so 15, 16, you pretty much have nothing to do. I'm going to write it over here. X minus 9 plus 6. So we want to simplify this, right, before we look at the absolute value. So let's subtract 6 from each side. I get 2. X minus 9 absolute value. This crosses out, greater than 0. I divide both sides by 2. You can almost think of this as your variable, so you're isolating your variable. In this case, we want to isolate our absolute value. Divide both sides by 2. We get, that goes away. X minus 9 is greater than 0. Is that right? Yeah. Okay, so, all right, I know, I forgot the absolute value. Okay, so when is this true? This is going to be, when is the absolute value of a number? When is it that you take the absolute value of a number and it's greater than, 0? That's pretty much going to be every single number except when this is 0. Right? Except when that the inside the absolute value is 0. So if you take the absolute value of 0, you get 0. And is 0 greater than 0? No. So the answer to this, right, if you think about, let's draw a number line here. Right? Here's 0. When is the absolute value greater than 0? So if I take the absolute value of 0.1, it works. I'm going to put a circle here. Absolute value of 0 doesn't work, okay? But the absolute value of every number to the right of 0 works. And the absolute value of every number to the left of 0 works. Every single number there works. So when you have this, the only time that this is not going to work, so our solution is, I can already start, all real numbers. So every single number in this world that I can substitute here will be greater than 0 except, and that's what we're going to find. Except. So to find the exception, I'm going to set this equation like this. I'm going to set it to 0. X minus 9 is equal. When is this equal to 0? And that's what we're going to find. X minus 9 is equal to 0, so we go plus 9 over here, plus 9 over here. These two go away, and x equals 9. So when x equals 9, this inequality is not greater to 0. So to prove it, let me write it. X minus 9 greater to 0. Let's substitute x. Let's substitute 9 for x, right? So I'm going to get 9 over here, minus 9. And 9 minus 9 is 0, which is obviously not greater than 0. So every other number in this world works except when x equals 9. So you can write the solution as all real numbers except when x equals 9. That's the only time it's not going to work. 9.1 works. I mean, look, if we put 9.1 over here minus 9, 9.1 minus 9 is 0.1. absolute value greater than 0, and then we take the absolute value of 0.1. It's just 0.1. Is that greater than 0? It works. And the only number in this world that's not going to work is, 9. And I'll give you a little, design map or something. I'll write some notes on what to do when it's greater than 0, less than 0 tomorrow. Okay. So I'm trying to, come on. Okay. Everything froze. Oh, come on. All right, guys, give me. Are you serious? All right, so let's try this way. Okay. Back. I want a backwards way of doing this. Okay, so next question, 18. -4, 3x minus 1 greater than 8. So remember, we're going to isolate our absolute value. So I'm going to divide this side by -4 and likewise by -4. So -4 goes away. I get 3x minus 1. Remember, sign is going to point to the left. It's going to be less than equal sign. And 8 divided by -4 is -2. So with this one, again, let's think about this. Right, here's -2. 0, 1, -2. Right? When is the absolute value of a number ever going to be less than -2? So if I take the absolute value of 5, so anytime you take the absolute value of something, like Christiana said, I believe this morning, it's going to be a positive number, right? So a positive number will never ever be less. I don't even need this. Be less than a negative number. So in this case, we can stop right here. There's no solution because the absolute value of no number in this world will ever be less than a negative. Okay, so that was 18. 19. Hopefully we actually get some problems and we actually work all the way through. -3 greater than -3. I feel like it's just this one. Okay, so +3 on both sides. -5, 2x plus 2. That's going to go away, and this is going to be greater or equal to 0. Another 0 problem. So divide by -5. Divide by -5. That's going to simplify to 1, and we're going to get 2x plus 2 less or equal to 0. Okay, so again, now this one, okay, so this one's a little bit backwards. So when is the absolute value of a number ever going to be less than 0? So if you think about this, if I take the absolute value of 1, will that be less than 0? No. If I take the absolute value of -2, will that be less than 0? No, because it's going to be +2. If I take the absolute value of 0.0001, is that going to be less than 0? Well, the absolute value of 0.001 is 0.001. Sorry, one more 0. Is that less than 0? No, it's not. It's never ever going to be less than 0 except once. Except one time, except for once, where it's not going to be less than 0, but instead it's going to be equal to 0. So there is only one answer, one value that's going to make this inequality true. And we got to find the value of x that we can substitute to turn into that number, okay, which is going to be 0. All right, so to solve this, we're going to set the inequality to 0. So 2x plus 2. When is 2x plus 2 ever equal to 0? That's what we got to find out. So we're going to subtract 2. Subtract 2. That goes away. 2x equals 0 minus 2 is -2. Divide both sides by 2. X equals -1. So when x equals -1, okay, let's substitute over here. So absolute value, 2 times -1 plus 2. 2 times -1 is -2 plus 2. That's going to give us 0. So this is the only moment that this is an equality. So the answer is just x equals -1. When x equals -1 and you substitute it and you plug it in, your inequality will work because you're going to get 0 on the left side, which is going to be equal to 0 on the right side. Okay? Oof, -10 plus a half x minus 4. So let's do plus 10 on both sides, right? Let's get rid of this. And we have 1/2 x minus 4 greater or equal to 0, right? So what I'm going to do is we're going to multiply both sides by 2. So I'm going to get rid of the half here. Both by both, this goes away. And I'm left with x minus 4 greater or equal still 0, right? So when is the absolute value of anything ever going to be greater than 0 or equal to 0? So in this case, right, the absolute value of whatever you take will always be equal to 0 or greater to 0, right? So if I take, so whatever this number is in here, right, if we look at this, graph it, here's 0, right? Let's put a circle on top of that. So if I take the absolute value of 0, is that equal or greater to 0? Yes. If I take the absolute value of any other number here, to the right of that will also be greater or equal to 0, and absolute value of everything to the left side will also be greater or equal to 0. So this one, no matter what number we plug in here, x is all real numbers, right? Every single number that we can think of, and you can plug it in here, will work. Okay, so that's your answer. 3/2 of x plus 2 plus 6 less than 15. Okay, so let's see if we get a decent problem here. minus 6, please. That goes away. This is going to be 9. Okay, so it looks like we might have something decent here. Divide by 3, and we're going to get 1/2 x plus 2 less than 3. So what's the absolute value of something? So if you think about this, I'm not solving it yet, right? So let's just think about when's the absolute value of something less than 3? Well, put a circle on top of that, -3. If I take the absolute value of 2.9 is less than 3, 2.8, 2.7, 2.3, any number here, right? So any number here between -3 and 3, if I take the absolute of any of those numbers, it will actually be less than 3. So when we actually solve this, what do we solve? This is an n problem. So 1/2 of x plus 2 has to be between -3 and 3. Wow, it's a little bit loud. Okay. So what are we going to do first? We're going to subtract this by 2. Subtract this by 2. Subtract this by 2, right? Get rid of this constant over here. We're going to get -5 less than 1/2 of x. What do you call? And -1 here. 3 minus 2. Now 3 minus 2 is 1, sorry. So now we're going to multiply everything by 2 to get rid of the, right? So we're going to multiply this by 2, multiply this guy by 2, and that guy by 2. So we are going to get -10 less than x less than 2. So let me graph that. -10, 2, I put a circle, I'm not going to shade them. So the values of x that I can come over here and plug it in here, right, are between numbers between -10 and 2. So again, let me pick something that's outside this parameter here. Let me pick 3. Well, let me pick a multiple of 2. Let me pick 4. If I go 1/2 of a 4, what's 1/2 of 4? 1/2 of 4 is 2. And 2 plus 2 is 4. If I take the absolute value of 4, it's just 4. Is 4 less than 3? Doesn't work. So a number on the right side of 2 doesn't work. So let me pick another number here. Let me pick -20. So let me replace x with -20. So 1/2 of -20 is -10. -10 plus 2 is going to give you -8. Absolute value of -8 is 8. Is that less than 3? No, it's not. So numbers to the left of -10 and to the right of 2 don't work. So let's pick a number inside here. You know what? Let's pick 0, because 0 is an easy number. What's half times 0? 0. And 0 plus 2 is 2. What's the absolute value of 2? 2. Is 2 less than 3? Yes, it is. Let's pick another number. Negative 8. Okay, so I'll put negative 8 over here where x is. Half of negative 8 is negative 4. What's negative 4 plus 2? Negative 2. What's the absolute value of negative 2? 2. Is 2 less than 3? Yes, it is. So again, you can always, check, okay, by picking numbers, whether in, to see if it really works, or outside the parameters here, in this case to the right of 2 or to the left negative, to say that they don't work, just to double check it work. Okay, so yeah, that's about it. We'll go over the zeros again tomorrow. Okay, I'll give you different problems of zeros so that it might be a little confusing, but that's it.